Okay, today, last time was the mean value theorem. Today is the extreme value theorem. So, no, just mean and extreme. All right, extreme value theorem says this, okay? If you have a closed interval, not an open interval, because it doesn't work for an open interval, only a closed interval. If you have a closed interval from A to B, and it's continuous, the function is continuous all the way from A to B, then if it's continuous all the way from A to B, there will be a minimum. There will be a minimum and a maximum somewhere in between A and B, including A or B possibly, as long as the function is continuous. So here's 3 examples of functions. In the top one, obviously the maximum's at the top, the minimum's at the bottom of this top first function, okay? The second one is supposed to be a horizontal line. So for the horizontal line, the maximum and minimum are all the points. All the points are maximums, all the points are minimums, okay? And this third one, the maximum is this point right here, and the minimum is this point right down here, somewhere in between A and B. So max could be an endpoint, or it can be somewhere in between, okay? That's the extreme value theorem. How do we apply the extreme value theorem? Well, when we're working with the extreme value theorem, we want to know what's happening to the line. Okay, we want to know where's the mins and the maxes and what's happening with the line in between those. Is it increasing, decreasing, what's going on? Okay, so we're going to figure out all that stuff. So here's a function. And first of all, what we need to find when we're working with this stuff is the critical numbers. The critical numbers are going to be, for the most part, where your maxes and minimums occur. It's every once in a while you won't have a max or min and a critical number, but for the most part, that's where your maxes and mins are. So how do you find the critical numbers? Well, critical numbers is when you take the first derivative and set it equal to 0 and solve. Okay, that's how you find critical numbers. So what's the first derivative of this first one?
6x squared minus 18x plus 12.
Okay, so you set the first derivative equal to 0. How do you think we solve for x here? Factor, the dreaded F-bomb. Yeah, factor. So when we factor this, what do we take out first? 6. Take out a 6 and you get x squared minus 3x plus 2. So it's x minus 2, x minus 1. So x equals 2 and 1. So 2 and 1 are our critical numbers. Okay? Then, that's critical numbers. So that's one section of what you're doing today is finding critical numbers. Another thing you'll be doing today is finding out whether things are increasing and decreasing. They're increasing if the first derivative of the function is greater than 0. They're decreasing if the first derivative of the function is less than 0. Okay? So, what do you do with this? Once you get the critical numbers, how do you figure out whether it's increasing or decreasing? Well, that was kind of a loud bite. So we got 1 and 2 are our critical numbers. What's in between 1 and 2? 1.5. So we're going to test 1.5, we're going to test 0, and we're going to test 3, because they aren't 1 or 2. So we're going to test values around there. The easiest one to test is 0. If we put 0 into the first derivative at 0 is what? 12. What's the first derivative at 3? Well, if I'm doing a number like 3, I'm going to stick it into the factored form because it's just easier. What's 3 minus 2? 1. What's 3 minus 1? 1 times 2 times 6 is 12, right? What's the first derivative at 1.5? 1.5 minus 2 is negative 0.5. 1.5 minus 1 is positive 0.5. Negative 0.5 times positive 0.5 is negative 0.25. Negative 0.25 times 6 is like negative 1.5. I'm pretty sure it is. Okay. Negative 1.5. See how this is negative, positive, and positive? So this function is increasing from negative infinity to 1. It's decreasing from 1 to 2. And then it's increasing again from 2 to infinity. So that's how you figure out if something is increasing or decreasing. You test values in between the critical numbers. So you're going to find critical numbers, and then you're going to do test values. Okay? Now, not everything is as simple as the first one. Okay? Let's look at this one. Okay? What's the first derivative of g? 3x squared plus 2x plus 1. How does that factor?
That's going to be
Yeah, okay. Yeah, nobody can factor this, can they? If we try the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. If you look at this, problems with my singing, Liv? What's 4 times 3? What's 4 times 3 in the real world? 4 times 3? Thank you, Mr. Ricky. What's 4 minus 12? What's the square root of negative 8? It's an imaginary number.
It's not possible.
So there are no critical numbers.
That means it's just a straight line. Right?
There are no critical numbers. No, if you actually look at the graph, it goes like this, and like this. Not a straight line. Okay, so there are no critical numbers, so we can just test any number, like the but we can't test 0 because what's the slope going to be at 0? 0. If we try any negative number or any positive number, yeah, because we're testing it in here. Oh, we can test 0. Duh. I was looking at the top equation. If we put 0, what's g prime of 0? 1. So anywhere it's going to be increasing. So it's going to increase from negative infinity to infinity. Okay. Oh. What's the first derivative of this?
Something.
E2x minus 6 times 2.
So it's 2e to the 2x minus 6. What's the first derivative of e? 0. Why is the first derivative of e 0? E to the first is just a number. It's 2.718281828904590 whatever. All right. So if we set this equal to 0, how do I solve this? Don't say you don't.
I thought you were going to tell us.
Way to go, Matthew Maher. So you divide by 2 and you get e to the 2x minus 6 equals 0, right? Then as Matthew said, take the natural log of each side. So 2x minus 6 equals, well, what's the natural log of 0? Nope. Nope. Undefined. So since this is undefined, can we find critical numbers? No critical numbers. We have no critical numbers. Okay? So is it increasing or decreasing? Okay? So we take this, if we put like a 3 in here. No, let's put we could put a 3 in there. So we get 6 minus 6, which is 0. E to the 0 is 1. 1 times 2 is 2. So at 3, it is increasing. If we put in e, somebody take e to the negative, like e to the negative 6. Calculator.
0.0024787522.
So whether x is positive or negative here, it's always going to be a positive number. So it's always going to be increasing. So it's negative infinity to infinity for this one as well. I think this graph goes like this and then like this.
Why does that mean it has no critical? Wait, it goes.
Because there have no maximums or minimums.
Can you just graph it then and then see like that would be the easiest.
Shh, Bella,
So
Bella,
I didn't
Critical
say
thinking here.
you're ruining what they're supposed to be doing.
Sorry.
All right. Yeah. But you have to give it a range for it to look for the minimum or maximum. All right. How would we do this one? Oh, what's the square, or what is the first derivative of this one?
1/2 x.
squared plus 4 negative 1 had to be the natural log of
Let's
2.7.
spread up.
So it's x over the square root of x squared plus 4.
Yes.
Because the 2 and the 1/2 cancel. Hey, Bella. Shh.
Sorry. Happy birthday.
All right. So now, if we set this equal to 0 and solve it, what do we get? Well, let's multiply both sides by the square root of x plus 4. Or the square root of x squared plus 4. You get x equals 0. What's our critical number?
0.
Critical number equals 0. Okay? So at 0 is the split where it's increasing or decreasing. I multiplied both sides by the square root of x squared plus 4. And the square root of x squared plus 4 times 0 is 0. And so then you're left with x equal to 0. Okay. So your critical number is 0. You may. All right. So where is it increasing or decreasing? Okay. No. That's where its min or max is. All right. So where is it increasing or decreasing? Well, we take like 1. Put f of 1 into x over the square root of x squared plus 4. So you get 1 over the square root of 5, or 1 over something. So it's going to be positive. Okay? If we put f of negative, let's go at negative 1 in here. Okay? We get negative 1 over 3, right? And so that would be negative. So it's decreasing from negative infinity to 0 and increasing from 0 to infinity. Last one. Okay? The sine of 2x. What's the first derivative of the sine of 2x? Cosine 2 times the cosine of 2x, because it's cosine of 2x times 2. Chain rule. All right. So, where is the cosine? All right. So, if we set this equal to 0 and divide by 2, the cosine of 2x equals 0. So, where is the cosine of 2x equal to 0 at? So, where is cosine equal to 0? At 0 and at pi over 2, cosine of x is equal to 0 at pi over 2 and 3 pi over 2, right? And negative pi over 2. So if you put a 2 in there, 2 times what is pi over 2? 2 times pi over 4 is pi over 2, right? So at pi over 4, what about if I would go to 3 pi over 4, it would be out of the domain, right? So I couldn't do 3 pi over 4. So it's pi over 4 and negative pi over 4. That, if you take the cosine of that, it'll equal to 0. So those two spots. So the critical numbers are pi over 4 and negative pi over 4. And the increasing, decreasing, I don't know if they'll ask you an increasing or decreasing for this. So if they do, you just try the cosine of 0. What's cosine of 0? 1. So it's increasing in between those two. So we'd say it's decreasing on the other sides of those two. Okay? All right. So that's the basics of what you're doing today. We get out at 55. No, 5 after. 5 after we get out. So we got plenty of time for this.